We are on Unit 4, Lesson 11, solving for logs. We already did common base. Okay, that's what this is talking about. We use the method of common base to solve exponential equations when we're able to use the same base. But it's not always going to work out so nice and easy. So we already saw this power. Okay, the power rule in the last section where you have the power come down in front of the log. And that's going to be the premise of solving for our variables. And remember, you use logs when variables are in the exponent. So if we have the x equals the 8th, the method of common bases, remember, was 2 to the 2x equals 2 cubed. All right, because 2, 4, 8, and 2 squared is 4. So then you set them equal to each other and solve. Now, the log approach is you would get the value with the exponent by itself. So that 4 to the x has to be by itself. And then whatever you do to one side, take the log, you do to the other. So you have log of base 10. You can use base 10. We're going to get into some other logs that we can use. 4 to the x equals log of 8. Power rule. X log 4 equals log 8. Okay? And then divide both sides by log 4. And then go to your calculator and put log 8 over log 4. I thought I had the calculator up. Hold on. You can see you didn't have our main screen. We have our fraction. Log, and remember, you don't have to put the base 10. Some of you were confused in class about to the lessons. So we have log 8 over log 4. Enter, and there's your 1.5, which is what we got from the other method anyways. When you had the 2x equals 3, divide both sides by 2, you got 1.5. Always use log 2 base 4, base 3, base 5, whatever. It all works out. It'll all be the same. Okay? Now, here we go with these. Solve each of the following equations for the value of x. Round your answer to nearest hundredth. So you can see they're all set up so that we already have the base raised to the exponent by itself. Log 5 to the x equals log 18. X log 5 equals log 18. Okay? There you go. Divide both sides by log 5. So in your calculator, you have log 18. So all I'm going to do is bring this guy down, and it was 18 divided by 5, enter, and you got 1.79, which it says round to the nearest hundredth. So you got 795, which rounds to 1.80. Okay, so this is 1.80. Next one, you have log 4x equals log 100. X log 4 equals log 100. Divide by log 4. Divide by log 4. Again, put it right in your calculator. 3. Next one, x is in the power. Log 2, 1560. X log 2 equals log 1560. Divide by log 2, divide by log 2, and pause it, slow it down, whatever you have to do, put it right in your calculator, 10.61. Okay, so that is as basic as it gets. If we have a little more challenging problems, maybe you have a binomial in the exponent, but as long as you have a variable in the exponent, you use your logs. Okay, so this one here is slightly different, all right, because what we have here is we have, like I said, the binomial, okay, but we're still going to do log 6, x plus 3 equals log 50. X plus 6 equals log 50. All right, so same premise, same exact thing, divide both sides by log 6, and when you put that in, okay, log 50, over log 6. So let me get my calculator out again. So log 50, delete, 50, oh my heavens, 50 over log 6, enter, 2.183. So 2.183. So x plus 3 equals 2.183. Okay? Now, just like you solve a basic algebra problem, minus 3. So don't be afraid to always use your calculator. You don't want to do that in your head. Minus 3, enter. So you get negative 0.816658. And use these answers, than the 2.18334. Don't round too early. So it says round to the nearest hundredth. Negative 0.82 is your answer. Okay. Next one, same thing. Log of 1.03. So the x over 2 minus 5 equals log of 2. X over 2 minus 5. I didn't need that one there. So put that binomial in parentheses. Okay. And then you got log of 1.03 equals log of 2. Divide both sides by log of 1.03. Log of 1.03. And then you have x over 2 minus 5 equals whatever that log is. Okay. What is this line? This line means nothing here. I don't know what that is. Okay. So then you have equals log of 2, log of 1.03, add 5. Okay. So 5's gone. So you have x over 2 equals this guy here. And then you multiply both sides by 2. Okay, this whole thing by 2. Because this will cancel here. And take the minute and put it in your calculator. And what you should end up with is 56.9. Make sure you put it in your calculator. It's 56.90. Okay? Put it in and make sure it works. All right, now we're moving on to a concept that we've already seen. Okay? But we don't like this formula. I don't like it. So this is your growth and decay. Remember I told you it was AT equals 1 plus or minus R over T. Oh, forgot the little a. Remember the little a is the initial amount. All right, so again, growth and decay, but now we're looking for the t. So there's going to be a variable in the exponent, therefore you're going to have to use logs. So you have your biologist is modeling the population of bats on a tropical island. He first starts observing them. There are 104 bats, so that's your little a. The biologist believes that the bat population is growing at a rate of 3% per year. Write an equation for the number of bats, BT. Okay, so the number of bats is 104, 1 plus 0.03 to the t. There it is right there. Okay, if you want to combine, be my guest, 104, 1.03 to the t. Okay, using your equation from part A, determine algebraically the number of years it'll take for the bat population to reach 200. So the 200 equals 104, 1.03 t. Okay, now you have to solve for the t. So that means we need to get this by itself, the 1.03 raised to the t. So that means that we need to divide both sides by 104. Okay, divide both sides by 104, therefore it's gone. Okay, I hope you don't run out of space here. I'm going to run out of space. So I'm going to go to a new page here. So what I have is 200 over 104 equals 1.03 t, which you already have. So we're going to do the log of both sides. The log of 201.04 equals log 1.03 to the t. Okay? So then remember the t comes out in front. So this comes down here equals t log 1.03. All right? So now we got to solve for t. You need to divide everything by log of 1.03. Everything by log 1.03. So let me show you how to put this in your calculator. So what we have here is we have a fraction, and we have your log base 10 of, put another fraction in there. 200 divided by 104. Okay, and now that's all over the log, same base 10, of 1.03. So you got to be very careful when you put these in. Enter, and there you go. 22.12. Round your answer to the nearest year. That's what it says. So it is 22. Okay? If you don't have a calculator, you got to make sure that you practice with the calculator. Try it when you get in class. Know how to plug these in. Okay, and that was part B. That was part B. That's your answer. All right, 22 years. Exercise 5. Now we are talking about decay because it's declining. So the stock has been declining in price at a steady pace of 5% per week. Okay, remember, the T I told you doesn't always have to be years. It could be weeks, hours, months, whatever. Stock started at a price of $22 per share. Determine algebraically the number of weeks it'll take for the price to reach $10. So when you plug it in, all right, what do we have? We have your ending amount. Your ending amount is 10, and it equals 22.5. That's your starting. 1 minus 0.05 to the T. Okay? So you do the 10 over 22.5 equals 0.95 T. Okay? So we're going to go to the page over here where I have more room. All right, maybe you can fit it in. You can write smaller than I can. My heavens, what was it? Oh, there it is. 10 over 22.5. So I'm going to take the log of both sides from right here. Here to here. That's the step I'm going to. So I'm right there. I'm going to log both sides because that exponent is a variable. So I'm going to do log. I know this is crazy. So I'm going to do log of the 10 over 22.5 equals log of 0.95t. I got a little bug flying around. So this comes down again, equals t log of 0.95, divide by log of 0.95, divide by log 0.95. Okay, so I'm going to the calculator, and I'm going to put log. I kind of, just fill in what I need. So log of, I think this was 10 over 22.5 all over, I think it was 0.95, right? Yeah, thanks. Okay, and enter it. And I have 15.8. So let's go back and read the question. 15.8. And that is, where am I? Number of weeks, determine how it's around to the nearest week. So I'm going to take that and make it 16 weeks. Okay, 16 weeks. Okay, now I'm going to want you to try these last two. And what happens with the last two is you have to get this by itself right here. Okay, and then log both sides. And this one here, you have to get this one by itself. Okay, so I'm telling you, in this one, letter A, you add 3 first and then divide by 4. This one here, you just divide by 17. Okay, so I want you to try A and B using the methods by putting the logs in. Okay, and I am going to look at those in class. Okay, so make sure you have those done. And if you don't have a calculator at home, you better get them done during advisement or lunch or whenever you can get a calculator and do the work. All right, I guess I will see you in class.